Hey there, Comp202. My name's Ari, and in this quiz I'm going to be walking you through 3 different problems that use loops and the random function. So in this first one, we're going to use a loop to count from 0 until n, where n is randomly chosen from the set of 0 to 100. In order to randomly choose anything, we need to import. And we're going to import this built-in Java function, java.util.random. Alright, so we're going to assign a random number. So we have to start by creating a new random. I'm going to just call it number. We assign this by saying new random with some empty parentheses. Then we can now use this new random function later in our code. So I'm going to say that integer n is equal to number, which is our random function. We're going to say it's integer. And because it's less than 100, we're going to put in 100, and that will be our max capacity. Alright, so now we're going to do a for loop. So basically in a for loop, you have the initial condition, you have the final condition, and you have the increment by which you're going to increase. So for this one, we're going to define a new integer I and set it equal to 0. For our maximum, we want I to be less than n, so that whenever I gets to n, it will stop. And we're going to increase I by 1 every time. The plus plus is the increment by 1. And whenever we do this, we're going to have system. We're just going to print, and we're just going to print the I value. So this function is now going to count for us. So what the for loop is going to do here, it's going to count by 1 from 0 to n. So this should work now. We're going to just open this up. And if we save and run the code, you can see here that it goes 0 to 31, meaning that the random value that was chosen was 31. If we run that again, it comes up with a different number. This time it's 49. So we know that n was 49. Just one more time, it comes out as 36. So you're going to have a different n value every time, but you're still going to be counting by 1. So the keys from this one is that you have to remember to import the random and then assign a random function and then use that to assign a variable, which here is an integer. And yeah, don't forget your semicolons. Alright, in the second part of the problem, we're going to compare 2 different random numbers between 0 and 100, and we want to tell the user which one is biggest. So that means that we need to use a random function to get 2 different integers, and then we need to compare the integers and control the statement based on the size of these integers. To start off, we need to import the random again. So java.util.random, make sure you capitalize it. Pop a semicolon after that, and then we just put in our normal stuff. Alright, so now we are going to define the random once again. This is the exact same as the last problem, so I'm just going to call the random this time random. You say new random, put in those open parentheses, and then that's defined. I'm going to use that to make an integer called a, which we're going to define as that random function and as an integer that is less than 100. We're going to do the exact same thing for an integer called b, so that we have 2 different random numbers. And we're still going to define that to 100. There we go. So now what to do with these? Now we have generated 2 random numbers. So now we use an if statement that if a is less than b, then we want to print to the user a is less than, and then you just add in the b because you can just add the strings together. Almost forgot a semicolon. Okay, so then the next one, same thing. So let me just close that off. And then on the off chance that it happens to come up with the same ones, we'll make a special case for that. A is equal to b. You use the double equal sign for your equality. It's not an assignment. Alright, so that should be pretty clear. So now I'm going to run this program. We're going to save it. And just run so we can see in this case that, see on the bottom here, in this case that our integer a was found to be 39 and integer b was 55, so it gives you the statement that 39 is less than 55, which is a true statement. Run it one more time. You get that 11 is less than 84, 4 is less than 11, 81 is less than 84. I'm trying to get a greater than 1. There you go, 25 is greater than 17. So just another fun add-on to this, if you don't want to press the run button every single time, you just keep the program running for a certain amount of times. I'm going to do this using a while loop. So I'm going to go back up to the top of my code and put in an integer that I'm going to call repeats and define it as 0. And then I'm going to put in a while loop. So this while loop, it will, as long as the condition is met, it will keep going. So while my integer repeats is less than or equal to 10, it's this, everything underneath here, underneath my open bracket, is just going to keep going. So now if I go back down to the end of my code, at the end of each round on this while loop, I'm going to put that repeats is going to increase by 1, which is the same as repeats increase by 1. Alright, so now if you think about how this is going to work, you have the repeats starting at 0. It's almost like your lives, but they're going up. So it goes through once, repeats goes back up to 1, goes through twice, repeats goes to 2, goes to 3. So you're going to see that this is going to go through the process 10 times. Okay, so we're just going to close up all the parentheses we have open here. Alright, so we're just going to take a look at the code. So right now it's the exact same in the middle. We've introduced a new integer, and we're going to repeat it 10 times. So whenever I save this and run it, we get 10 different statements, because it's going to pick a new integer each time. And you can do this for any amount. I can even make it go for a very long time. So while all this is true. Okay, so now the process will continue indefinitely, which is pretty cool. So if I'm going to save this and then watch it go through, it's going to be really cool. So it's just going to keep doing the process over and over and over and over and over again until I force it to stop. So that's number 2. Alright, so in our last problem, we're going to have to check if a random number n is a prime. We already know how to make random numbers from those last 2 examples, and we know what a prime is. A prime is something that can only be divided by 1 and itself. So we're going to be using booleans, for statements, if statements, and obviously our random function. I've already done the import of the random. Alright, so in this one, we're going to do the same random thing. I'm going to call this make random, just to highlight that it really doesn't matter what you call it. So it's really just the definition of this function. Okay, so then this is new. Okay, and then we're going to define our integer, which has been n, equal to that function that we just defined. And we're going to get an integer out of it that is less than 100, just to make things simple. Actually, no. Let's not make it less than 100. We'll get some big numbers out of this. But next int instead. Oops. Alright, so that doesn't have a bound this time, so it's not going to just stop at 100. It's going to give me any integer in existence. So it's basically up to like 2 million or 2 billion before it turns into a long. Now we're going to introduce a Boolean, which is a true or false kind of statement. It can either be true or false. And we're going to call this Boolean is prime. Initially, I'm going to set this Boolean equal to true. Alright, so now we're going to introduce a for loop. Alright, so the initial, we're going to introduce integer I, and it's going to be equal to 2. We're not going to have to see if anything is divisible by anything less than 2, because less than 2 is just 1. We want to keep our I value less than n over 2. It's just n over 2 because if you divide a number by 2, it's the biggest factor. And we're going to increment it by 1, so the increment function, the plus plus. So now we got this nice little set, and then for that for loop, if, you can use an if statement with a modulus. So this means that if when you divide n, our random number, by every integer it could possibly be divisible by, the remainder is 0. That means it's divisible by something that's not 1 or itself, so it means that the is prime statement is false, as prime numbers can't be divided by anything. And now we're going to print it to the user whether it's true or false. Alright, so to go over what every bit of code here does, we start with our normal stuff with the random. So this is generating a random number. Assign Boolean. So in this one we're going to try to divide the random number by all possible numbers. If the Boolean is prime is false, this implies that it's not a prime number. If it's true, it implies that it is a prime number, and I'll print that to the user. Bracket problems going on there, so we'll just fix that up. You just saw how I need to close the first part of that. I'm going to try that, and we come up with a very random number that negative a lot of digits is prime. I'll put this in more simple terms by confining this to 100. You can see that 22 is not prime. 55 is not prime. And if you want to compute a whole bunch of these at once, you can do exactly what we did with the last question and use the while loop by just defining the repeat variable and then incrementing by 1 every time. So I hope you understand. Feel free to ask me any questions about these codes, and good luck!